little messy, but because we'll index into the first pair and then the first element, and then now.
Okay, if current number is greater than average, then I should say because the number of users is at the dominant.
Okay, we need to here plus. Okay, I think this looks good. This is the cost to. So this is the. I forgot what it's called. What's it called? Where it takes
Okay.
distance up and down. What is it called again?
Count the numbers that are
Yeah,
dominant. So I'm gonna go and
the Manhattan distance.
from right to left initial I'm gonna have sum equal sum of nums, and then I'm gonna go for I in range 1 and then len nums. Then I'm gonna check if the current number, if nums I is greater than the sum. So sum gonna be minus equals. I'm gonna adjust the sum, subtract the current element, and then I'm gonna divide the sum by the numbers left on the right. So it's gonna be numbers left on the right gonna be n minus 1 minus I. It's gonna be n minus 1 minus I. And if it's so, I'm gonna increment the result by 1. And then here I'm gonna have result initially 0, and then I'm gonna return the result. Let's check if it works. Oh no. Okay, so I'm gonna have len n equals len nums, and here n, and then running again, division by 0. So and up to the n minus 1. Okay, 5, 4, 3, 0. That's interesting. Rs plus equal 1. If nums I is greater than average, sum n minus 1 minus I. So let's print what's gonna be there. I, then I. Okay, I got it. So from 0 to n minus 1. 2. Here 1. Let's submit. Okay, next one. Merge adjust and equal elements. Nums must repeatedly apply the whole merge operation till no more changes can be made. Okay, if any two adjusted elements are equal, let's do this. Brown noise. Can you guys hear the brown noise? I wonder. Desktop audio. Yeah, probably you hear it. Let's see. Given integer nums, you must repeatedly apply the following merge operation until no more changes can be made. So I have, if I need to adjust an elements are equal, choose the leftmost such adjustment pair in the current array and replace them with a single element equal to their sum. After each merge operation, the array size decreases by 1 repeat the process until updated no more changes can be made. The final array after possible merge. Okay. So the problem is I add the value to the stack, and then the size 10 to the power 5. Yeah, I add the value to the stack, and then again, like I add the value and check, go to the next one, check the value in the stack and check the value of the current pointer. And if they are equal, I add them to each other. I pop the element from a stack, I add them together, and then I push in new sum, and then I check again, and then etc. etc. And then in the end, I'll just read the values from a stack that's left. So I'm gonna go for, I'm gonna have the stack is equal list, and then I'm gonna go for I in len nums. I'm gonna go stack push. Oh, first of all, if len of stack, if let's say stack is true, I'm gonna go stack -1 if stack -1. Let's call it num is equal, let's say nums I. Let's go num is equal nums I, and then while stack is true, so it's not empty. Well, stack and stack last element in the stack is equal to the num. I'm gonna go stack dot pop, and then I'll go num is equal plus equal stack dot pop, and then it's gonna continue, and then in the end I'm gonna go stack dot push, then this num, and then I'm gonna return stack. In range nums. Okay, append. Three, 4, 8, 3, 7, 5. Okay. Okay, next one. Count subarrays with a cost less than or equal k. You are given an integer array nums and the integer k. For any subarray, define the cost as cost. Return an integer denoting the number of subarrays nums whose cost is less than or equal k. So cost is basically max minus min for subarray minus multiplied by the length of the range. So the length of the subarray can be, so the length is quite big. So n squared of the subarrays will not work. Okay, so the idea I have is to do sliding window, something like if I have something like 1, 3, 2. So initially the So I need to maintain max and min for this window. So if I find the maximum, a maximum window that satisfies this condition, so the cost is less or equal k. Any subarray gonna also work because the subarray gonna be have like maximum probably less, minimum probably more. So this multiplicator gonna be upper, but the range by r minus l plus 1, this one actually gonna go down. So it's not obvious. This statement is not obvious right now. I said it like I said it was. Mm,
Supposed to be like that. Don't touch it with dirty fingers. People already make it dirty over.
so the number of subarrays of nums whose cost is less than or equal k. The number of subarrays of nums whose cost is less than or equal k. Yeah, this multiplication is screwing things up. If it was like just max minus min, it would be much easier. Can I somehow convert this task to r minus l plus 1? So let's say we have max minus min, let's call it, with the LR over multiplied by r minus l plus 1. And then I reduce the window by like let's say moving right pointer to the left. So how it's gonna be? So max minus min, and here left r minus 1, left r minus 1, and then so this delta will decrease, and then the delta will decrease if I reduce it, and the r minus l plus 1 also gonna decrease. Yeah, so like any subarray also gonna work. So like the so we need to find the maximum window and do the sliding window approach. So in this case, let's go. And so let's say I have, that's a bad example, 1, 2. All examples are kind of weird. Okay, well, let's say we have 1, 3, 2, and then k is equal to 4. So it seems like it's all subarrays. Okay. Here it's like 4 plus 3 plus 3. Not actually all. That's those examples, they don't help at all. So I'll go and try to implement this approach. Where is this window? Okay. So I'm gonna go for, let's say L is equal to 0 for I this call and the call len of nums, and then for right in range n, I'm gonna call the cost. So I need to maintain minimum and maximum and do that efficiently. So I'm gonna have these two priority queues, PQ min equals a new let's call min PQ, and then PQ max is equal to this one, and then the k is 10 to the power of 15. Okay, so I go, and here I need to somehow to PQ min PQ max, and then I'm gonna have this add a pair. Min PQ. So for the range R is equal. So for every new R, I need to check if I will add PQ heap Q heap push, and then here I'm gonna push into PQ min. What's the default? Is min heap? Python min heap. Heap. Okay, min heap. Okay, I need heap p5 heap push, and then okay heap push. Okay, so what I'm gonna do here? Where is it? Is it here? No. Yeah, here. So I'll do PQ, and then I'll push this tuple like array, and then I'm gonna be nums R, and then I'm gonna have this index R, and then yeah, this one gonna be, and then heap PQ heap push PQ max. I'm gonna have nums R, but I'm gonna multiply it by, because I need to make it max heap, so I'm gonna have this -1 multiplied by nums R, and then R, and then I need to check what's the cost, and then the cost gonna be, so I'm gonna have this here as kind of result variable, and then the cost gonna be PQ max. It's gonna be heap 0 returns the smallest element, heap 0. Okay, heap 0. Okay, so PQ max 0. Okay, so first of all I need to adjust the max Q and min Q. So I'll do while PQ min 0, and then here 1 is less than L, I do heap PQ heap pop. That's probably not required, but I'll add it as now. Heap PQ heap pop and then PQ min, and then while PQ max and PQ max 0 1 is less than L, I'm gonna go heap PQ heap pop PQ max, and then I'm gonna check cost. So I need to adjust the window. So I push to the heap, and then I need to check what the current cost. The current cost is gonna be PQ min, PQ max 0 multiplied by -1, -1 multiplied by PQ max, minus PQ min 0, and then here multiply by the size, multiplied by the L minus Q. And then here R minus L plus 1. Then here it's gonna be cost. And then while the cost is greater than K, I'm gonna go cost. So I need to pop this, remove the element, the left element from a heap. I'm gonna have L plus plus, and then I'm gonna need this one, L plus plus equal 1, and then I'm gonna do this cleanup, and then I'll recalculate the cost. And then in the end I'm gonna have res plus equal right minus left plus 1, and then I'm gonna return res, something like this. So let me check it again. So I do left, right, while R in range R, I'm gonna push this element, and then I don't know. Here 0, here 0. Here is 0. Here is 0. physical 4, output 5, here output 10, here output 3. No? Hip pop Q. Use. So the output, where is this else? Okay, 4K output 2. Let's go. Okay, so the next one, maximum score using exactly K pairs. You are given two integer arrays, nums 1, nums 2 of length n and m respectively, an integer k. Let me just bring the water. Okay, maximum score using exactly K pairs. At least they gave some example, non-trivial. So for this problem I have 1, 3, 2, and then 4, 5, 1. And then k is equal to 2. So I have to choose the indices, and for the k is obviously, oh, k is actually 100. So this length is for maximum 100 and this length is also maximum 100. So I need to choose the in pairs, like 2 pairs here, and then say I can choose 1 and 5. No, I can choose 1 and 4 or 1 and 5 with 1. And then from here I can choose 3 and 5, 3 and 5, or I can choose 3 and 1. And here I can choose 3 and 1, yeah, 3 and 1. And then for the last one, I can start with 3 and I can choose 4. Oh, yeah, 3, 4. Or I can choose 3 and 5. 3, 5 as a start. If I choose 3, 4, again, like 2 choices, 2 and 1, and then, no, 2 and 5, then 2 and 1 here, and then here also 3, 5, so it's gonna be 2 and 1, only 1, 2 and 1. So next I need to do cast a scorer. So so here 4 plus 15, 19, 4 plus 3 and 1, 7. So here score, no, yes, 7. Here score 8. Here score 3 by 4, 12, 22. Here score 12 plus 2, 14. Here score 15 plus 2, 17. So obviously this is the largest score. Maximum achievable score. Okay. So the function that I want to optimize is like this: sum of the sum of the let's say a I take k, and then b, let's say we have longer one, a I k, and then b j k, and then this is k from 1 to k, capital K. And then I can like, again, like I can choose like the sum is maximized when maximized its parts. This is maximum, this is maximum should be, and then the multiplication should be the maximum. So what I wanna do is like, how to do that? So the order seems matters, and I should split this array into, let's say, k sub-arrays, so that, and then in every sub-array I can choose a maximum, and then here also if I split it in a k sub-arrays I can choose a maximum, and then like do 1 to 1. So how should I split it? So if I do the brute force, what's gonna happen if I'm gonna do the brute force? It's gonna be 100 elements. Let's say we have k to be selected. So it sounds like a backtracking with some memoization. And let's say you have a sub problem. It's like, what's the maximum product for, let's say, if you have like array left for the nums I, you say I, and here j, say start 1 and then start 2, and then, so I'm more inclining to do this with a backtracking approach, with like just memoization, and then like see how it's gonna go, because I don't see actually a smart way how I can like solve for this equation. it's like all over the place. I should maximize the relative and like the relative product, and then kind of split this array. So yeah. So I'm gonna have this backtracking. So I have 19 minutes. Okay, let's call it def bt. So I'm gonna have this map for the values. Max product, can the values be 0? Yeah, they can be negative actually. Let's call it gp, like that, or like mem, and then here gonna be equals minus, okay, absent is equal 10 to the power of 6 plus 1, and then okay, minus 1, and then mem gonna be absent multiplied by num, okay, say n1 is equal len nums1, and then n2 gonna be len nums2, and then absent multiplied by n1, and then the whole thing for I in range n2. Let's say n2, and then here n1. So the first index is gonna be the index in the nums1, and then the second one gonna be index in nums2. So I need to select, figure out what, so I'll have this function def bt, and then there I'm gonna have this start1 integer, start2 integer, and then nums1 a list of integers, and then nums2 is gonna be also the list of integer, and then I'm gonna have this k, so k left. Okay, and here also absent for, and then here multiply by k actually, for this one in range n2. So we're going to have this k left integer, and then I'm gonna have this bt, so it's gonna be maximum, so I'm gonna return int, and then if k is equal 0, I'm gonna return 0, and then if k mem, so mem gonna be this humongous mem, gonna be list of list of list of integer, humongous array, and then here mem start1 start2, and then k is not equal absent, I'm gonna return this. Otherwise I need to go for I in range start 1 and up to len nums 1 minus so if you need to select, let's say 1 is left, okay, 1 is left, so I want to go up to the k minus k plus 1. So len minus 1 plus 1, okay. And then the same for j in range start 2 len nums 2 minus k plus 1. I'm gonna go, okay, max gonna be 0, then or like max gonna be 0, and then if I is equal start 1 and j is equal start 2, I'm gonna have max is equal bt equal bt. So I use bt start 1 or like I plus 1 and then j plus 1, and then I'll have this nums 1 nums 2 then k minus 1 and then mem, and then max is gonna be, so it's gonna be nums 1i multiplied by nums 2j plus bt, and then otherwise else the max are gonna be max and the same one. I just want to avoid the situation with negative values and then setting the max 0 initially. And then I'm gonna check mem start 1 start 2 k, gonna have max, and then I'm gonna go and gonna return max, and then I need to call this bt function, actually bt 0 0 nums 1 nums 1 nums 2 then mem k and then mem, and then I wanna return this one. Will it work? Else let's just call it I don't know why it's saying that. I just call it return 0, and then here print mat mem. Okay, in this case I can have this mem It should be three-dimensional. Can it be like this? Okay, that's now should work. Print f. Okay, st1, st2, then k. Okay. Can it be like this? No. Output 0, 0, 2. Oh, used 0. Okay, let's call it used k, and then k, and then used, and then here used, here int. So if the used is equal k, I return 0. So here gonna be used, k, and then used plus 1, and k, and then used plus 1, g used 0. Can be like this. Mem used. Oh no, 4 here, and then here output here 4, here output 6, and then here the output is 0. So what's the problem here? do I'm printing a new thing. Print. Next. Okay. Try to submit. Oh, that's interesting. Why it is out of the time? So here nums1 is the size of, like, I assume it's something like big. So what's the size of this array? 1, like 10, maybe 20, maybe 50, and this one also maybe 50. Time limit exceeded. Oops. There should be somehow there should be somehow the optimization. What if I gonna move this BT function, like use this mem how to optimize that so that it doesn't give me this time limit exceeded. Why is time limit exceeded here? So I go here, yeah. Go away. Okay. So at least thumbs up if you like this video. So I was following it for 1 hour. I didn't manage, so I had some family routine. So I wasn't able to to start earlier, but I doubt I can solve it. Like if I was given like 30 more minutes, I doubt I can come up. Maybe yes, maybe no, I don't know. I'll think about this problem during this week and then see what I can do. But backtracking generated me like time limit exceeded. And like I don't see many optimizations I can use here except like memorization. So if I go and like run again, it's gonna be interesting if let's check like, so if I go to my profile, if I go to this last key, what? Did you see that? But during contest it was time limit exceeded. Oh no, no, it's not the one. Okay, let's go to this one. Like very inefficient way of solving problem. So let's go next one. Or go filter question ID. Question ID. Okay, like this. No. No. Oh yeah, this one. So let's try to submit. Thank you. Okay, let's submit. Yeah, the same. Go solutions. What is LCS? Oh, please don't tell me that like optimize solution. I guess it's because of recursion. Because of this recursion in a column PT and a Python was not very efficient because of that, I guess. But there is some optimization, so it's like double for loop for J max. If n is less than m. What? Okay, so okay. So he always changes the size, flips it. And somehow builds up the solution. But why it's optimized? Whatever. It's already been like over the 1 hour. Yeah. I'm gonna stop recording. Was it even recorded? Yeah.